Now let's do an example. In a train station, the trains are stopped from crashing into platforms at the end of their runs by means of a spring. If the force constant of the spring is 222,000 newtons per meter squared, and the usual compression of the spring by the incident train is 6 centimeters, calculate the potential energy stored in the spring at that compression. So the first thing we need to do in order to solve this problem is to write down every single thing that we know about this. So for example, we know that the spring constant of the spring is 22,222,000 newtons per meter squared. And the compression is 6 centimeters. Now there is a problem. Now this gives me that the compression is 6 centimeters. 6 centimeters is not an SI unit. So the first thing we need to do is change that into meters. The formula we are going to use is 1/2 kx squared. And I know that my x is 6 centimeters. I need to convert it to meters. 1 meter equals 100 centimeters. So this implies that 6 centimeters equals 0.006 meters. Okay. Now, given this formula, potential energy is equals to 1/2 kx squared, I can plug in the values. So we'll have 1/2 k, the value of k, the value of x, and square it. So then all I have to do is plug these numbers into my calculator, and I come up with 3996 Newton meters, or 3996 joules. Another example is a guitar string is 65 centimeters long, has a tension of 55 newtons, and is displaced 8 millimeters at its midpoint. How much potential energy does it have? Now this is a very interesting question, so look at this question very carefully. What are the things that are given to you? Number one, it gives you that the guitar string is 65 centimeters long, and it has a tension of 55 newtons, displaced 8 millimeters at its midpoint. So this problem says that the guitar string is 65 centimeters long. Now there's a problem. There's a centimeters in here. And it says that the tension is equals to 55 newtons. And it also says that my Y displacement is 8 millimeters. Now there is another problem, that it is saying that it is 8 millimeters. So the first thing I need to do is I need to find the formula that I'm going to be using. So I know that my potential energy is going to be given by 2T y squared over L. Now the next thing I need to worry about are these units. Okay, so for my units, I am going to convert this into meters. What do I know? 65 centimeters times 1 over 100 centimeters equals 1 meter. Right? 1 meter equals 100 centimeters. So this implies I will have 0.65 meters for my length. My second one is tension, which is 55 newtons. Well, that's fine because it's newtons and that is an SI unit. The next one is Y, which is 8 millimeters. I know that 1 meter equals 1,000 meters. So this means when I need to convert it to meters, it will be 8 millimeters times 1 over 1,000 millimeters equals 1 meter. Right? Now the millimeters will get canceled, and what will I have? 0.008 meters. Once I have all these values, all there is left to do is plug and chug. So what I can do is I can rewrite 2 tension, which is 55 newtons. I can plug that in. Y, which is 0.008 meters, which I can plug it in, divided by the length, which is 65, or 0.65 meters. And put it into your calculator and come up with an answer. And since this is potential energy, the answer will be given in joules. And I will leave that up to you guys to figure out what the answer is.